So now we're going to start section 14.3, which is about change a variable into polar coordinates. So just as a refresher about polar coordinates, remember that the idea is, so if you were in rectangular coordinates, you represent a point here by a x comma y, and that point is really represented by the x is the horizontal distance and y is the vertical distance. And so in polar, we represent points a little bit differently. Instead, we represent a point by an r comma theta. So that same point. Instead, r represents the distance the point is from the origin, and theta is this angle right here from the positive x-axis up to that line segment. So also we want to remember that we have some conversion equations that help us convert between rectangular and polar or vice versa. So those equations are x equals r cosine theta, y equals r sine theta. We also know x squared plus y squared is r squared, and tangent of theta is y over x. So you can kind of see those equations if you put these two pictures together into a single picture here. So here's theta, here's r. You can use the Pythagorean theorem to get this one. Tangent is opposite over adjacent. That's how you get that one. All right. So we have that. And why are we even going into this whole discussion about polar coordinates? If you remember the last section, we were looking at some double integrals. So some double integrals are much easier to evaluate in polar form. So, for example, examples of regions that you might want to consider looking to polar coordinates. So regions that are circles, or what are called cardioids, where the graph kind of looks like a heart, and graphs that are called rose curves. So if your regions look like any of these kinds of graphs, you might consider using polar coordinates, and it should work out to be easier than working with rectangular. So let's look at some regions and make sure we know how to describe those. So here's an example. I want us to use polar coordinates to describe each region shown. So let's go with our first one, part A. Let's say the region I'm gonna look at here. It's 1/4 of a circle of radius 2. So we want to use polar coordinates to describe this region. So I want to describe R, this region R, with polar coordinates r comma theta. So let's think about what are my values on R. R, the smallest r can be is 0, and the furthest r can be is 2. So r is between 0 and 2. Now let's think about our angle theta. What angles do I have here? I'm looking in the first quadrant, so theta is between 0 and pi over 2. So here's my description of my region in polar coordinates. All right, let's look at another one of these. So let's say I'm looking at this annular region. So I want to make sure I have enough room to draw this graph for you. Okay, so here's a circle of radius 1. So I'm going to try and draw the best circle I can here. Oh, this part was a little rough. There we go. And a circle of radius 3 here. And the region I'm talking about, it's the annular region, so it's the region between these two circles. So again, we want to describe this region using polar coordinates. So R is represented by points r theta. Let's think about R. The smallest r can be is 1, because you're outside of, or you're missing that inner circle. And then the largest r can be is 3. And then think about your angles theta. Theta goes from 0 to 2 pi. So this is how I would describe that region in polar coordinates. R is between 1 and 3. Theta is between 0 and 2 pi. So now that we've talked a little bit about how to write regions in polar coordinates, let's talk about how to take your double integrals and switch them into polar. So the first thing you're going to do is what you've done kind of in the previous example. You're going to take your region R and you're going to convert it to a polar region. And so now when you're looking at part of your region here, it's going to be bounded between two functions, maybe of theta. R is bounded by and you're going to have some fixed values on theta. So you're looking at theta between an alpha and a beta. And so our formula for a change of variables to polar form, I'm going to convert my double integral over r. And now it's going to be, I'm going to replace x by r cosine theta, y by r sine theta, and then this dA becomes an r dr d theta, and my bounds, theta goes from alpha to beta, and r is bounded between g1 theta and g2 theta. So here, one important thing to note is that you get this extra r when you convert to your polar form. So when you're making your change, don't forget that extra r.